Truth is ever to be found in simplicity, and not in the multiplicity and confusion of things.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
Da 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 da. Oh yeah, baby Isaac Newton.
Matt, that was a perfect way to start the New Year podcast.
Yeah, with a bit of Newty baby.
Oh, I mean, does it get any better than him?
Isaac Newton, the bark of physics.
January 4th, 1643. Or 25th of December in the old calendar, Matt.
Was Isaac Newton born on Christmas Day? Probably. Really, we should consider it 4th of January, just because the way the calendar worked back then.
I think we should. Yeah, exactly. So happy New Year, Matt, and happy New Year, everybody. Are you having a good start to the year? Let us know. Get in touch.
Well, it's been quite a good start to the year, hasn't it?
Oh, it has.
There's something quite exciting.
Go on.
Everyone started noticing that Betelgeuse, or Betelgeuse, depending on how you want to say it,
yeah.
Had started to get really dim, and it is quite noticeable, Jamie. Whenever you get the chance to see it, look at Orion, just notice how much dimmer Betelgeuse is.
Oh, really?
Yeah,
well,
yeah.
It's
well, it was in the top 10. It was in the top 10 brightest stars, and it's no longer in that top 10 for the first time in decades.
Oh God, I blame Elon Musk and all his satellites.
But I don't think for this time. I don't think it's that.
Not his fault. Okay,
not his fault. But we shall be speaking about that later on, and that actually does play into the guest that we have this week, Moriba Jah.
Absolutely.
Who you may have seen on TED Talks, but I wanted to get this one out because I think that the pollution of space might be a big topic this year, particularly with things like Starlink. So yeah. I thought I'd have that one in. Jamie, reason why I wanted to speak about Betelgeuse is because there's been a lot of speculation, of course, because everyone's thinking, maybe this is it. Maybe we're about to see her go supernova.
Oh my goodness. That is what I'm talking about.
If you refer back to our The Sun episode.
Oh, that classic, yeah.
Yeah. We go through the process of how a star, when it runs out of its nuclear fuel, collapses in this kind of runaway cataclysm.
That's right.
And then it'll blow up into a great big supernova as all the material bounces back out of this kind of collapse of the stellar core. Now, Betelgeuse is 900 times the radius of the sun. So it would stretch right the way out to Jupiter if it was plonked in the middle of the solar system.
That's big.
It's absolutely ridiculous. In fact, it's so big and actually so near, it's only 640 light years away. We can image the surface of Betelgeuse. Now, if it does go supernova, it would be such an amazing thing in the night sky.
Yeah.
It would be brighter than the moon, brighter than the full moon probably.
Yeah.
And it would be clearly visible up in the day sky, possibly for a couple of years. So it would be absolute. And the thing is, you'd be able to see this. It's not like a sort of slow event. It's a really quick event. Now, has this dimming meant that this is what we're going to see?
Well, has it? Well,
the answer, as always, Jamie, with exciting headline news, is it's not really. I know.
People are always letting me down, Matt, especially the papers.
Imagine how big the surface of Betelgeuse is, right? You've got this bubbling hot gas that we can see from here, 640 light years away. And really, it's the processes that are going on in this gas, the atmosphere of the star, that that essentially are what's causing this dimming. And it's very, very unlikely that we can actually see what's happening in the core from what's happening visually. Do you see what I mean? And the only way that, so basically we know that Betelgeuse has started to use helium fusion rather than hydrogen fusion to make helium. It's now fusing helium to make carbon. We know that. But the moment it switches to carbon fusion, then it becomes prone to collapse, because obviously the carbon's very, very heavy and it will suddenly collapse. Now, it's not a visual thing, though. The way we'd be able to tell that is from the neutrinos that it's putting out. But we just don't have neutrino detectors that are sensitive enough to see this neutrino stream come off. So,
did anyone get a neutrino detector for Christmas?
Let us know. Point it at Betelgeuse and let us know. But basically, we just don't know, Jamie, whether this dimming has anything to do with whether we're going to see something amazing or not. But it looks unlikely, and that we'll still have to wait hundreds, if not thousands of years for this stellar event, which is very, very short in terms of astronomical times. But of course, in the lifetime of you and me, Jamie, it's
well, you know what,
Matt?
Morgan Freeman in The Shawshank Redemption said that hope can kill a man, but I remain forever hopeful.
I'm going to kill you, though, Jamie.
Oh no! Happy New Year! This is the year Matt finally has enough of my bullshit. You don't know my new address, do you?
No,
exactly.
I've actually got a couple of students called Hope. Now I'm a bit scared of them.
Oh, God.
Jamie, the final flight of 2019 was the Chinese.
Yes. Long March 5. I'm
trying to speak Chinese. As we shall see. That's going to be quite important.
It really is. Matt, it's getting their moon ambitions back on track, don't you think?
And Mars.
Oh, yeah.
So it's both. You'll see that Long March 5 plays quite a big part in quite a few things they're doing. So shall we just have a quick preview of 2020 before we go over to Moriba Jah?
Let's do a quick snapshot of the year ahead. Very exciting year.
It's one of those biennial times of the calendar, Jamie, that we can actually go to Mars.
Finally.
There's going to be 4 Mars-tastic trips this year. So let's start with the big one. Is NASA 2020 Mars rover.
Oh, yes.
And of course, there's going to be a repeat performance of the 7 Minutes of Terror.
Oh, don't say that.
The thing is, we're going to have to wait till 2021, February, before that 7 Minutes of Terror. So even though these are launching this year, they won't be arriving until next year.
Jeez Louise.
That's how far away Mars is. It's so depressing, isn't it?
Yeah.
So, yes, 17th of July. July is going to be an epic month, Jamie. You've got to strap yourself down for July because there's so much going on. 17th of July launch. And, that will be February landing. It's got 23 cameras on board. It's also, the exciting bit is the sample caching system. So it's going to be drilling holes and keeping some of that rock.
That is exciting.
For an Earth return.
Ooh.
It's got a new wheel design and a better turret, and the turret is better for holding an instrument. So you're going to like this, Jamie, because I know you like a good acronym.
I do.
So this is 2020's acronym of the week.
It's a new
Space
feature.
Acronym of the week. Sherlock.
Okay, I like it already.
The scanning habitable environments with Raman and luminescence for organics and chemicals.
Now that I like. Most of them I'm like, is that the best you could have done? But Sherlock, I'm into.
Sherlock. So yes, Sherlock is going to be mounted on the robot's arm, and it's got lasers and cameras, and it's going to be looking for microbial life.
Get in.
Luther Beagle. I mean, this is great, isn't it? They're all named after after British detectives Luther, Sherlock. So here we go. Luther Beagle, the principal investigator of the Sherlock instrument, said, "Key driving questions are whether Mars is or was ever inhabited, and if not, why not? The Sherlock investigation will advance the understanding of Martian geological history and identify its past biological potential."
Is he from the Wild West in the 1800s?
Luther Beagle. Isn't that a great name?
Great name. Well, maybe it's after Van Dross, the cardigan-wearing legend.
Luther looking after Sherlock, and Beagle, of course, is the name of the doomed British Mars lander.
That's right.
Yeah, wow.
R.I.P.
Or Charles Darwin's boat.
That's very true.
So Sherlock's only it goes 2 inches above what it's trying to look at, and uses a magnifying glass, just like Sherlock would have done. And guess what the name of the camera on board that particular instrument is going to be called?
Columbo?
No, who was Sherlock's helper?
Oh, Watson.
Watson.
Yeah.
Watson is the name of the camera. So it's Sherlock and Watson are going to be looking around.
I love it.
What's really exciting is Sherlock's going to be carrying tiny bits of Martian meteorite that have come to Earth, and we're taking back to Mars.
Oh.
Isn't that crazy?
That's nuts. Well, imagine how expensive that little bit of Mars rock would be, Matt.
Yeah, it's crazy.
Imagine that.
And it's also it's going to be carrying bits of spacesuit as well, I believe, that it's going to be testing. Now, not only will 2020 rover be taking Sherlock, it will also be taking a freaking Mars helicopter.
Ooh, yes. I mean, God, can you imagine the images from that?
So we are going to have to wait till 2021 till we see the beautiful pictures of a helicopter taking off on Mars. I just simply can't wait. That's going to be so brilliant. And then mission number 2, Jamie. We've only covered mission number 1. And of course, ESA and Roscosmos's mission to Mars has been named after you, Jamie.
It has.
The host of the Interplanetary podcast, the Franklin Rover.
Franklin Rover.
I don't know who this Rosalind person is.
No, not important.
Sharing it with you. Rosalind Franklin Rover is going to Mars on the 25th of July, a week after the 2020 rover.
Oh, that's busy old time, as you said.
And of course, just like you, Jamie, the rover was mostly built here in the UK.
Yeah.
It's twice the size of Opportunity that
just
died
like
last year, but a third the size of Curiosity, just like you.
Blimey.
And yes, the wheels and suspension were paid for and built by the Canadian Space Agency.
Oh, God love them.
So that's very cool, isn't it? Roscosmos are going to be supplying the radioisotope heater units that's going to keep the rover warm. And it's going to be looking for biosignatures from the past using its analytical laboratory drawer, or the ALD.
Oh, yes.
And do you want to hear my second space acronym of the week?
Oh, go on.
Is your mama. Your mama.
Okay.
Is Mars Organic Molecule Analyzer.
I'll accept that one.
Mama. Is the rover's largest instrument and is going to be looking for organic molecules. And it's basically lasers and mass spectrometers built in Germany and at NASA's Goddard and at various institutes in France. So,
wow. We're really going in on Mars.
Well, of course, the only problem with the Rosalind Franklin rover is that it might not go in this window because of the parachute issues. But there have been some good news coming out of tests recently done there. So hopefully it's back on track. But you know space, Jamie, you know space. One of these missions is not going to go, I'm pretty certain.
I do, yes. Well, we'll keep our fingers and toes crossed firmly.
Yeah, so China, Jamie, this is an exciting one.
Oh, yeah.
Mars Global Remote Sensing Orbiter and a small rover, which is going to be called the Huzheng 1 or HX1.
Wow. More Mars stuff.
Yeah, well, this is 4 Mars missions. This is Mars mission number 3.
God damn.
And that's going to be launched probably in the same week as the European / Russian Franklin rover. And that's going to go on the Long March 5 heavy lift rocket. So that's why it was so important that worked. It's a decade after China collaborated with the Russians on the doomed Phobos Grunt mission.
The lander carrying the rover will use a parachute, retro rockets, and an airbag to achieve landing. What do you think about that? It's going to be powered by solar panels and probe the ground with radar, also performing chemical analysis of the soil to look for biochemicals and, as you said, biosignatures. What's a biosignature, Matt? Is it when people ask me for an autograph?
No, it's more like when I walk into your bedroom and go, "Oh, what's that smell?" That's a biosignature.
Oh, right.
So, yeah, it's more like that. So, yeah, it's likely to be flying in the same week as that ESA mission, or it can go in a window that lasts until the 5th of August, and again landing in February 2021. It's also going to probably do the old caching of samples for retrieval in 2030.
Ah, gotcha.
Now, what nation do you think are involved in the 4th mission?
Well, I know this because I saw it on Twitter. Matt, it's the United Arab Emirates.
We're going full circle. What's the name of this mission?
Hope Mars Mission.
And you said hope will kill you.
Oh, this is what I'm worried about.
I'm blooming hope that doesn't that the rocket's not that powerful that it ends up hitting London.
Yeah,
it's not built by Werner von Braun, is it?
Oh, don't say that.
So, yes, it's on a Japanese rocket, so that's going to be taking off and going to. It's only an orbiter, so it's not a rover. This one. Okay. When I say only, it's pretty impressive that the UAE are going to be sending stuff.
What's it studying, Matt?
Into deep space? The atmosphere, looking for trying to answer some of these questions about what the hell's going on with Mars's oxygen and hydrogen, and how it loses it into space. Yeah,
tale as old as time.
But we won't see that get into orbit until July 2021.
Okay, we'll wait for that one.
There's 3 landings in there: a Chinese, an American, and a European / Russian. Now, it has to be said, the odds for landing are particularly poor. The Russians have never managed it. Everything they've sent has failed. Same with the Europeans, and particularly the same with the British as well. All a bit of a disaster. The USA, of course, manage it pretty much every time, so they're absolutely bang out at doing it. But it's going to be stressful.
It is going to be stressful, but exciting nonetheless. We go forward.
Right. So, what's happening at the moon, Jamie? What's happening at the moon this year? Do you think?
Well, December 2020, Matt, China, Chang'e 5, the first sample return mission to the moon since Luna 24 in 1976. Chang'e 5, again, will use the recent developed launch Long March 5 heavy lift rocket.
So there you go. So that's, yes, Chang'e 5, basically carrying on the success of Chang'e 4. So if that really does go in December, that's going to be super exciting.
Incredible.
Lots more cameras landing on the moon.
Yes.
But it's the fact that it's going to be picking up samples and returning them. Incredible.
They've got their sites fully set on the moon, haven't they, China?
Yeah, so that it's what China, this is it. China are really looking for space dominance.
They really are.
We've got a couple of things happening out with asteroid samples. We've got OSIRIS-REx that's going to attempt scraping the surface of Bennu in July. Bennu, and Hayabusa 2 will be landing in Australia in December.
Quality. Really excited about that. It's close to my heart, that one.
Yeah, that's a mega one. There's a couple of sun missions. We've got ESA's Solar Orbiter launching this year.
Yeah.
And the Indian ISRO Aditya L1. And I presume the L1 stands for the fact that it's going to the Earth-Sun Lagrange point, L1,
Quality.
to study the sun.
Go on, India.
Yes. Quite a few things happening with humans in space, Jamie.
Oh, yeah.
We've got, of course, something that this is what we've said at the beginning of 2019 and 2018, that we're going to see Boeing and SpaceX put humans into space. But hopefully, for goodness sake, it has to happen this year.
We have said this before, haven't we?
well, for literally the last 2 years. I mean, it's starting to become stressful now. So yeah, February we might see SpaceX launch astronauts for the first time, and then a little bit later we'll see Boeing with the CST-100. So that's a big one. That's big, and it's got to happen this year. I mean, it really does have to happen this year. Long March 5 again, Jamie. Long March 5B. There will be the maiden flight of a Long March 5B, which is the crewed Chinese spacecraft, important for their space station, etc., etc. And maybe
it really is, yes,
an attempt at a moon landing with humans. And of course, India are going to be testing their Gaganyaan capsule this year as well.
Incredible stuff.
America, China, and India all testing their human capability of getting into human space with humans.
I'm ready.
Like how I said that.
Take me.
Yes, space stations. Looks like China are going to be trying to get bits of their space station up in October. The new Heavenly Palace.
Love that.
Could be delayed till 2021. I'm going to do a quick. I know how you love these, Jamie, but I'm going to do a quick rundown of maiden flights of rockets.
If this isn't quick, and I know our listeners, they will have a revolt.
Ready?
Go.
Ariane 6. That's a big one.
It's not quick enough.
The Japanese H3.
Yeah.
Which is actually quite similar to the Ariane 6, the sort of smaller version of it. The big one that everyone is just going to lose their shit over if it happens is, of course, it's going to be Starship going orbital. Well, I just can't even begin to imagine how amazing that will be. A bunch of sea launches.
Yeah.
It looks like Sea Launch, the company itself, are back in sort of business. So we might see a few sea launches. There's going to be the maiden flight of Launcher 1. Of course, that means that we might see orbital launches from the UK very soon.
Yeah.
The maiden flight of India's small satellite launch vehicle, the SSLV.
Uh-huh.
The maiden flight of Firefighter Alpha.
Yeah.
That's pretty exciting. First orbital launch attempt by the Astra commercial small sat launch vehicle.
Mm.
Maiden flight of the Chinese Ceres 1.
Tick.
Maiden flight of the European Vega C.
Vega.
Maiden flight of the Taiwanese Hapith 5.
Well, that does make me Hapith.
Nice. Maiden flight of the Japanese Blue Whale 1.
Oh, I love whales. Stop killing them, though, Japan.
Here's a big one. Maiden flight of NASA's Space Launch System.
Damn. Please go well.
Maiden flight of the Zhilong 2, also known as the Smart Dragon.
Yeah,
another
that
Chinese.
Is true.
Maiden flight of the Kaizhou 11, another Chinese. Mm-hmm. Maiden flight of the Long March 6A. Maiden flight of the Chinese Nebula 1. Have you spotted?
Oh, absolutely killing it.
Yeah, this is, China are killing it. They really are. Crikey.
Let's see how they get on. Good luck, China.
But I think one of the biggest news stories of this year is going to be internet satellite constellations.
Yes, here we go.
Already starting to get into the news, of course, of the SpaceX ones that are. Did you see that image?
I was just about to say, that photo blew my mind. It's like, jeez.
There's a couple. There was one that of the people in Norfolk going, "What are all these UFOs overhead? Like I keep seeing like light after light after light. We're being invaded." And then someone pointed out, "No, they're the Starlinks." And there's photos that were coming out, which is like, "Oh my god, it's unbelievable." But then that photo of like multiple frames of trying to take a picture of Orion.
Crazy.
And it's like, oh my word, absolutely smeared to hell. Of course, they're going to go higher and become less visible than that, but still, it's a problem, as we shall hear from our next guest. OneWeb, Jamie, flies under the UK flag, by the way. OneWeb, of course, also putting up probably 600 satellites by the end of the year.
Damn, that's a lot.
Both Starlink and OneWeb will probably have some form of operation, i.e. be selling to customers at some point in the year.
So SpaceX expects to begin operation of its Starlink 2020, 720 satellites launched by the end of the year. That's a lot.
An extra 50% of working satellites. Yeah.
Well, good luck, everybody. We remain sceptical.
Do you want to hear the interview with our next guest?
I absolutely want to hear it. Let's roll that tape.
Well, this is Moriba Jah, who's an American space scientist, and you can see his TED Talks, but he's a really, really nice guy, really cool, and what a distinguished career he's had as well. Just take a listen.
Incredible stuff.
A cootie!
The Interplanetary podcast, putting the ace back into space.
I've been reading a little bit about your background. It's a very interesting journey. You're actually the same age as me, I notice, although you look a lot better on it. Can you tell us a little bit? Can you tell us a little bit about your journey and how you got to be where you are today and what you're actually doing today?
Yeah. So once I graduated from high school, I actually enlisted in the U.S. military, and my job in the U.S. military as an enlisted person was to safeguard nuclear weapons, nuclear missiles in Montana. I was stationed in Montana, and interestingly enough, the skies in Montana are quite dark at night, which is phenomenal for people that have never seen what the stars look like in a place with very little light pollution. I highly suggest it. But interestingly enough, during my night shifts and looking up at the stars, because there wasn't any real terrorism going on, so I was protecting the United States from random cows that would go around the nuclear missile sites, and I would notice these dots going across the sky, and the dots occasionally it would be kind of these shooting stars or meteors. But then it dawned on me, well, it's not a plane. These aren't shooting stars. So what are these dots that I see going across the sky? And when I did a little bit of research, lo and behold, these things are human-made objects orbiting the Earth, satellites, debris, and all this stuff. And so that really, I couldn't believe that with my naked eye, I was seeing things like, satellites orbiting the planet. And I think that really solidified my interest in orbital mechanics and that sort of stuff. And so I left the military after my enlistment and went to study at this place called Embry-Riddle Aeronautical University in Arizona. And I studied aerospace engineering, and I never really thought, realistically that I'd be working in space. But I had a pretty good mentor, Ron Madler, who he had worked in orbital debris during his graduate work at University of Colorado at Boulder, and he was a very good mentor. And I got involved in the Arizona Space Grant program. It's a NASA Space Grant program in Arizona, and I started doing research regarding orbits, and that's kind of how all that began. I went off to graduate school at the University of Colorado at Boulder under the late George Bourne. He was a great mentor as well, and got more and more involved in astrodynamics or orbital mechanics, the science that studies how things move in space. And one thing led to the next, and I ended up getting a job at NASA's Jet Propulsion Laboratory as a spacecraft navigator, which really means just being on a team of people to help deliver rovers and orbiters to other planets and other celestial bodies. And I was really focused on Mars, and I did a handful of Mars missions, and one with the European Space Agency Mars Express, and then one with the Japanese, this Hayabusa that went to asteroid Itokawa. But sometime in 2004, there was a conference. I'm part of several professional societies, and there was a conference for astrodynamics that was on Maui. And I went with my wife and son to Maui, and in 9 days, basically my family fell in love with the island. And I was told in no uncertain terms that my days at NASA's Jet Propulsion Lab in Pasadena were numbered because I needed to find employment on Maui. So in a moment of weakness, I was able to find a job on Maui, and I left JPL and started basically working for the Air Force Research Laboratory, which has a number of telescopes on top of Mount Haleakala. And that's where my focus shifted from Mars to near-Earth orbit. And I started really studying this population of human-made objects around Earth, and this is where I started getting involved more in the current debris problem and that sort of thing.
Yeah, so I've seen that you describe yourself or are described as a space environmentalist. What exactly does that mean, and what are the sort of things that we should be concerned about?
Yeah, so I would say this. 3 things for people listening to really consider is that near-Earth space is geopolitically contested. That's been the truth ever since the launch of Sputnik. Different countries, vying for the ultimate high ground of space and different services and capabilities that space can afford. Now that landscape is changing drastically and being dominated by commercial activities. So the second theme is space is commercially contested, even though the Outer Space Treaty says that it's res communis, near space belongs to all of humanity. There's sort of this squatters' rights sort of mentality in that even though we have no deeds for orbital space, physics tells us that two things cannot occupy the same space at the same time unless bad things happen as a result. And so whoever gets to certain orbital altitudes and is able to populate those with their assets pretty much owns that orbital altitude. It's going to be very difficult if you have tens of thousands of satellites at a given orbital altitude. Let's call it an orbital highway. Once you've populated a highway and you have a lot of traffic on the highway, it's very difficult for other vehicles to enter and participate in that highway. Which brings me, go ahead.
Yeah, well, I was just about to say, I mean, you're talking about these lanes. Is there a specific reason why there are kind of lanes of orbits?
Yeah, absolutely. And so this is great because it feeds into the third and kind of the last theme here is that near Earth space is a finite resource. And, even though one can think of outer space as being infinite, the region around Earth in terms of orbits is finite. And basically, here's the deal, Matt. When we launch satellites, we like to save as much money as possible. And there's this thing that we call gravity, which dominates how things behave in space. And so we try to take advantage of nature as much as possible. What are the natural flows, the natural accelerations that something will experience in space? That way we don't have to find artificial means of fighting it. It's almost like, if you want to navigate on the oceans, the easiest thing to do is for you to use the currents to take you where you want to go versus fighting the current, because that's an expensive proposition. So you should think of it very much the same way in space is that we have gravity, which is dominating the accelerations of all objects up there, and we don't want to fight gravity because that's expensive. And so because we don't want to fight gravity, there are ideal kind of orbital highways to put satellites on that give us the ability to have access to specific services and capabilities. One in particular is a region called, geosynchronous, which really just means that it's an orbital altitude, an orbital highway, where it takes a satellite about 24 hours to go around its orbit once. And as you can deduce, that is equivalent to an Earth day. And so the cool thing about that orbit is that when you put a satellite there, from the ground's perspective, because the orbital period is equivalent to an Earth day, it means that if you want, direct TV or satellite TV, you don't have to continuously move your antenna around. You just point it in a specific direction, and the satellite will generally be in the same region of the sky. So that's a Goldilocks orbital highway. That's great. But if that highway became unusable and you had to use propellant to fight gravity to stay in that same region in space, that would significantly decrease the lifetime of your mission and significantly increase the cost that would be passed on to users and all that other stuff. So that's why it's a finite resource. There's only one geosynchronous region. There aren't many of those. So we need to protect the environment, and this is where this idea of space environmental concerns comes in. This whole me being a space environmentalist is that I really want to achieve long-term sustainability of this orbital ecosystem, as it were, and very much trying to get people to realize that it is a finite resource and it's in need of environmental protection.
Yeah, I mean, talking about that geosynchronous orbit, I mean, I was reading a paper not that long ago that was talking about collisions that are already happening in that orbit, and I was absolutely amazed that something that's an orbit that's so vast, really, you've already got these collisions starting to happen. I mean, that looks to me like we're ruining our future almost, that we're ruining, like you said, this finite resource. Is this something we should be really, really concerned about?
The reality of it is this: we do have small particles that are always bombarding, actively controlled working satellites. Most of the stuff that's up there never comes back. So we're, what we've done to the oceans with plastics and whatnot is what we're doing to near Earth space. And what we need, kind of a global community to really embrace, certain tenets of sustainability, of sustainable behavior, if we want to preserve that environment kind of long term, because the services and capabilities that we depend on a daily basis are becoming increasingly uniquely space-based services and capabilities. So as an example, position, navigation, and timing, that's pretty much space-based. What does that affect aside from you getting directions on your phone? Air traffic, also on the oceans, maritime, things on land as well, using GPS and whatnot. The timing piece also manifests itself in financial transactions. Banking systems time transactions based on space-based position, navigation, and timing services. So imagine if we lost some of these capabilities, what would happen if you went to a bank and couldn't retrieve your money? That would be a bad day, not just for you, but many people would be, shaking their fists in uproar and condemnation. And that's just one of many services that is space-based. I mean, the internet itself, now we have both Amazon and SpaceX wanting to provide global internet. I've even heard of people wanting to get cloud computing services to be space-based so that they're not vulnerable to ground-based infrastructure activities and that sort of thing. So more and more, the technology that we depend on is service provided uniquely by space-based capabilities, and losing that capability would basically throw us back, a century in terms of technology.
Yeah, so that ocean analogy came up quite recently. I think it was Jan Werner at the at some European Space Agency meeting was talking about, can you imagine if, if he was talking about space debris, and he was sort of saying, imagine if the oceans, every single shipwreck was still on the surface, just how bad it would be to kind of navigate. But in a way, that doesn't cover the kind of speed and almost intractable. You can't. It's almost like these objects are going so fast, you can't just sweep them up. You can't gather them in, and you've got things like Kessler syndrome that are an additional problem on top of, say, like the analogy you made earlier on about plastics in the ocean. So this problem seems to be one that's extremely difficult to sort out. And is it more to do with trying to avoid there being this kind of massive problem in the first place, or is it we've already created a problem and we need to try and think of solutions to roll back that problem a little bit before it gets out of hand?
Yeah, so I would say it's probably the latter of what you said. And interestingly enough, Matt, one of the things that, this is one of the things that I think makes me a little bit different than some of my other colleagues is that, when I'm looking at sustainability, the United Nations just adopted 21 guidelines towards long-term sustainability in Vienna at the Committee on Peaceful Uses of Outer Space. And these 21 guidelines are a great start. I think they're insufficient, but it's a great start. The thing that's missing from these guidelines is that they haven't necessarily been motivated by other examples of successful sustainability that we've seen on the planet. And what I mean by that specifically is the knowledge that certain indigenous people have. So there's this thing called traditional ecological knowledge, or TEK, and it's the knowledge that people like the Maori in New Zealand, the Aborigines in Australia, the Inuit in the Arctic. These are indigenous people that have, for thousands of years, developed a process to thrive in regions with ecological scarcity, where they had to strike a balance with the environment and achieve sustainability that way. No overfishing, understanding the relationship between themselves and everything in a given ecosystem and how these things interact. Gathering careful observations, passing that down from generation to generation. These are things that, these tenets of TEK are things that I believe should be foundational to applying to space so that we can achieve space sustainability. And so that's one of the things that I'm trying to really push is tell people, listen, we don't have to reinvent the wheel on sustainability. Let's look at where certain indigenous people for thousands of years have found a few gold nuggets on how to behave to achieve that.
When you've got the exploitation of space that's being driven mostly by capitalism, can you think of with that principle in mind, can you think of a solution that you've thought of that could apply in sticking satellites up and using this near space environment?
Yeah, so one of the things that I firmly believe is that making lots of money is not mutually exclusive from environmental sustainability and doing good for humankind. So I think both can coexist quite nicely. And when I hear this question from you, one of the things that it brings up is, with the World Economic Forum has an activity right now on developing a so-called space sustainability rating, an SSR, that would act to incentivize sustainable behavior. And it would be a rating that people could get that's much analogous to a rating that people get for, in the hotel industry, 5-star hotel or 5-star restaurant. Well, here's a 5-star space actor that's behaving sustainably. And so we're actually developing that under this activity with the World Economic Forum. And I think that that can go hand in hand with supporting space commerce and helping capitalism in space, but doing so in a way that preserves that environment for money making for many, many generations to come.
Yeah, well, I suppose with the hotel industry, you've got the general public that are looking at things like the 5-star ratings and making their purchase choices on that. How can you twist that kind of model so that people want to just spend their money with the 5-star providers rather than the provider that's just turning around and saying, "Hey, I'll just do it cheaper," and presumably by cheaper they mean they're not going to bother working out how they're going to bring their enormous satellite down once it's run out of fuel.
So this is great. So one of the things that we're working on here at UT Austin, specifically to achieve this kind of space safety, security, and sustainability, are three things that I'm trying to deliver with our science and policy. Making sure that space is more transparent, making sure that activities in space are more predictable, and then gathering a body of evidence that can be used to hold people accountable for their behavior. So transparency, predictability, and accountability. Those are the three things that I'm using as yardsticks, measuring sticks for the work that we're doing. So to me, when I travel the globe and I speak to people, when you give people a choice, an option, when you say, hey, you can either invest in these things and you can get this return on investment in 5 years, but it's to the detriment of an environment and this sort of stuff long term, or you could follow this path, which will still get you money, still get you services, and almost guarantees that this is something that you could get for the foreseeable future, indefinitely. Most people will choose the latter, given that, especially if the transparency piece is there. So I want nothing to hide in space. I want all activities from all actors to be very transparent. If somebody blows up their own satellite in some orbit, I want that to be globally known, who did it, when, and then leave it to humanity to make some decisions on, how to take that evidence and kind of curtail these sorts of behaviors. Naming and shaming is something that is worked in the past in other domains for sure.
Yeah, that's really, really interesting. I mean, have you developed a system for showing this kind of transparency at all?
Yeah, so we've taken a very good first step at this, and we've developed this knowledge graph database called ASTRIAGraph, and it can be accessed visually through a web-based platform, and it basically shows a number of dots around the planet, all human-made space objects, and it's kind of like a crowdsourcing of multiple databases that shows all these opinions about what's in space. And these things don't necessarily agree with each other all the time, which makes it quite interesting.
Yeah, I was playing with it last night, and I sent it over to the guys in our Patreons over in the Discord, and the same question that came to me was, what are the yellow and orange and red smears in the map?
Yeah, so when it comes to ASTRIAGraph itself and that visualization, the yellow stuff are things that are working, and everything else is some version of garbage, whether it's an intact satellite, presumably a fragment of something, or a rocket body. So those are kind of the, and then gray is just I think just plain debris, and there's pink, which is we don't know what it is. We know that it's a human-made object, but we can't really. It's uncategorized. We don't have a category to fit that in. So it requires more information.
Oh, crikey. So, yeah, you really do get a kind of feel for the mess then, don't you?
Absolutely.
Yeah, it's. I suppose one of the problems with displaying it like that is that the area is so vast, and therefore the dots aren't really to scale. You kind of feel
exactly.
as though it's really, really cluttered, but it's not. So the second part of what I asked earlier about, do we need to roll it back a little bit? What are your thoughts on some of the missions that happened quite recently? I actually work in a town called Guildford, which is where they built the Remove Debris mission. Did you see that one? And what are your thoughts on those kind of missions? Are we going in the right direction, or do you think that's a bit of a false step?
Yeah, so I think it's technology that we need to develop. It's probably a so-called long pole in the tent. So the sooner that we can do that, the better, because the solutions need to be hybrid. I mean, some of it is curtailing our behavior to mitigate the further preponderance of debris. Some of it means grabbing stuff and doing debris removal for remediation of the current population. So there's a number of things that we need to do. I tend not to be a Lord of the Rings, one ring to rule them all kind of guy. I like having multiple approaches to be more surgical with stuff and all hands on deck sort of thing. And in fact, when it comes to the clean space activity, I was in Switzerland last week, and Muriel Richard from EPFL, she's going to be leading, I guess, this thing, on behalf of ESA. And I think there's an opportunity for collaboration between our research program here at UT Austin with ESA Clean Space. So I'm quite excited about it, actually, and I think it's a great thing.
Yeah, I mean, it just seems to be such a huge problem where you have to send up one satellite to get one satellite down. It seems to be it seems to be like a very, very hard nut to crack. Where do we go on from here? Is there any other kind of solutions apart from the incentivizing environmental awareness from the companies that stick these things up? These companies and space agencies developing debris removal systems. Are there any other kind of avenues to explore?
Yeah. So here's the thing, right? I think we need to have more candid conversations with a more diverse group of folks. I believe not only in diversity, but inclusivity. And to me, the difference between diversity and inclusivity is when the diversity has an equal voice. So to me, having a room full of people from all walks of life is insufficient. The people from all walks of life actually need to have part and parcel in the decision-making processes that ensue. I think having fora where we can have these very uncomfortable and candid conversations are needed. One example is with the Ascend event that's going to happen, inaugural one, which is going to happen in November of next year. That's going to be like TED Talk on steroids specific to space, which is great. And I think having people like these indigenous folks, maybe finding a way to get people from the Inuit and Aborigines and the Maori and those sorts of folks in the room to just get their opinion. Is like, listen, when you look at the skies, what do you see? Have you seen changes? Generationally through stories handed down, what's been the difference? I mean, they've witnessed climate change. They've witnessed changes in different ecosystems. I'm sure that they have an opinion about stuff in space. But everybody needs to be in that room, and I think having dedicated events that force that to happen, not just inviting people, but basically going out of your way to make sure that those people are in the room. Listen, one of the things that's very disappointing to me is I see a lot of technical conferences, and it's the U.S. and U.S. allies and that sort of stuff in the room, and it's like, okay, well, where are the Chinese in the discussion? Where are the Russians in the discussion? Where are the Indians in the discussion? So we need to find ways to get those people not just invited, but to make sure that they are critical and indispensable partners in coming up with solutions moving forward to try to achieve that space safety, security, and sustainability.
Yeah, that there are just so many parallels, aren't there, with climate change as well, in terms of trying to get all the stakeholders involved is an absolute imperative, isn't it? Because we're all suffering from climate change, and we can all potentially suffer from a space environmental catastrophe as well. Which kind of brings me on to one question. Obviously, we're just about to see the launch of these huge constellations of satellites. We've already seen SpaceX in 1 year increase the working satellite population by about 5%, and next year it'll shoot up even more. Are you pretty presumably there's a high, you've got a high level of concern about those constellations?
So I do, and the concerns that I have are the following. I'm very concerned about a tragedy of the commons, because again, near Earth space is a finite resource, and if everybody just behaves independently and in their own kind of self-interest, I believe that it is highly likely to be to the detriment of all of us. When SpaceX, for instance, with their Starlink satellites, when they automate maneuvers, sure, all the Starlink satellites know where each one is to within maybe a few feet. Do they know where the non-Starlink satellites are to within a few feet? No. So what's the decision-making criteria for being safe or getting out of the way? Right now, it's based on opinions from the U.S. Department of Defense, specifically U.S. Space Command, with these warnings of collision risk. Are these warnings 100% accurate and precise? No. They have their own flaws for a variety of reasons, which go beyond the scope of the podcast. But I can tell you that automation is the way to go. Eventually, automation based on the absence of great information, I think, is stupid, and I think is a dangerous behavior to have, to be honest. So I think prematurely doing these things doesn't make sense, and having this mentality of, well, we'll learn from our failures, we can't tolerate that in an environment that should be environmentally protected. So I have issues with that. All the constellation owners and managers, it's not like they've gotten in a room and said, we're going to hold ourselves to these standards and we're not going to move out of the way until we have, this is the way we're going to quantify collision risk. And these are we're going to all have a standard for when we move out of the way, who turns left and right, like these rules of thumb. That has not been done holistically. So that's certainly a problem that I see with the constellations. And I think one of the last things that I have a concern with is this. Mother Nature, from all of my scientific endeavors, I can tell you that what I've noticed is that nature always seeks equilibrium. Nature always seeks equilibrium, whether it's stable or unstable. There's several flavors of equilibria, but nature always seeks this state of equilibrium. And I can tell you that, if we're launching things every 2 weeks, which is what, I've heard SpaceX say, yeah, every 2 weeks we want to put up like 60 Starlinks or whatever. Really, do we believe that the environment can reach this equilibrium state every 2 weeks? Like, we don't even know what the impact is of launching all these things at that rate. Like, we should launch some stuff, observe it for a while, do some science, right? Do some knowledge gathering. This is one of the tenets of traditional ecological knowledge. Observe, see how the environment is reacting. And once we can kind of assess, okay, this is how the environment is moving towards this equilibrium. Now we know what the effect is of putting 60 things up there at a time with all this background clutter and the debris. Now we can be more informed and say, we should be launching at this rate. This is the right rate to launch at because we need to give the system time to reach this state of equilibrium or whatever. We don't even know that. So to me, it's just this kind of gold rush. Let's put as much stuff up there as quickly as possible in the absence of really understanding the dynamics of this orbital ecosystem. And I think that's we're out in front of the headlights, as they say. I think space activities is far outpacing a regulatory framework that can maximize orbital safety, security, and sustainability.
Yeah, that's some really interesting points. I mean, it's worth noting, isn't it, that ESA had to move one of its very expensive Earth observation satellites, Aeolus, earlier on in the year because they couldn't even contact SpaceX when one of their Starlinks was actually on a collision course with it. There was a breakdown even in just the most basic communication. So that it clearly hadn't been thought out at all. And the fact that we've got all these astronomers moaning about the light pollution, and that hadn't really been thought of before these things were launched. It seems like there was a whole bunch of unknowns that are now kind of rearing their ugly head. So I can clearly see the point that you're making there. It almost seems obvious. Is there a point you could actually get to, just like in the environmental climate change sense, that you have tipping points where there's a tipping point that once you've gone over it, you really will have a nightmare to try and row back to a previous position?
Yeah, so I can tell you this, right? One of the tenets of traditional ecological knowledge is understanding the carrying capacity of the ecosystem. I know that the European Space Agency, their space debris program in Darmstadt, they have a concept of orbital capacity, which I think is great because I fully embrace that. And I think that we haven't fully agreed on how to quantify that orbital capacity. Like, that's something that we should definitely all work on together, understand the carrying capacity of these orbital highways to sustain safe operations long term. And then, because that capacity is not just in the number of objects, but it's also dominated by the uncertainty around knowledge about where those objects are and how those objects are going to behave. I can tell you right now, the carrying capacity of air, of the air domain for air traffic, right now we have many, many more planes in the air, but we know where they're located much more precisely. 40, 50 years ago, there's no way that LAX or New York or even Heathrow could sustain the current air traffic because there was a lot of ambiguity with where these things were located, how they were traveling, and all that other stuff, and the technology to manage that. But as precision has gotten much, much better with space-based capabilities, in fact, we can handle many, many more objects, but there is a finite capacity, carrying capacity of the air to sustain air traffic. So the same thing is the same thing for space, man. There's a finite capacity of these orbital highways, and we need to be able to quantify this and make it very much known. And back to your point about the astronomers and the light pollution kind of stuff, yeah, I point back to traditional ecological knowledge. It's when you're looking at how to manage a finite resource, you need to get the voices and opinions of all people, even though you may not think it's relevant. Yeah, what does this do to the night sky? How does this impact science that's done on the ground looking at the heavens? Like you said, this was not something that was accounted for, surprisingly. But it's because people aren't thinking in this kind of holistic way. And we need to do that. We need to start doing that.
Yeah, I mean, it seems really that a bit like, say, the use of fossil fuels, that the manufacturers and the people profiting from those from the sale of things aren't actually paying the full price. So we've kind of learnt the lesson with fossil fuels and climate change. So is that a model that we should be kind of really looking at and saying, the people aren't paying the full price here for populating? If Starlink want to populate the sky with their internet service, then they're not paying a full price because there's a lot of other people that now have to do workarounds, and there's other people's lives that, like you said, I mean, I wouldn't want to be an Aborigine looking up at the night sky and have my sky changed, it changes it for everyone. So how do you make people pay the full price for something, or am I barking up the wrong tree? Shouldn't I be thinking like that?
Well, I think it's bringing these examples that are very real and meaningful into some common narrative where all of us can talk about this stuff. Like right now, if you go to like a space conference like the IAC, you're not going to hear this. You're not going to hear the voices of Aborigines and that sort of stuff because, well, what do the Aborigines care with satellites and that sort of thing? That's the wrong mentality. So having some sort of forum where it's not just, scientists and engineers, but it's also indigenous people. It's also kind of, people, everyday folks that maybe have supposedly nothing to do with space, but space is part of their heritage. We need to have this kind of candid conversation and bring up all these examples so that people can have an aha moment. I think when people are exposed to all of these sorts of things, I think it's much easier for people to say, right, I hadn't thought about that, and that is a good point. I think in general, 9 out of 10 times people want to do the right thing, whatever that means. But it needs to be known. It needs to be exposed. It needs to be discussed and talked about. And I think that's the first step.
Yeah, it's quite a fact. That's definitely opened up my ideas about the subject. I was just thinking, it kind of reminds me of spectrum itself, like the UHF spectrum or radio spectrum, that the way that they sell off chunks of it and saying, well, you can now operate in this one chunk, that it's this finite resource that actually is becoming more and more expensive and tighter and tighter and tighter, and it's highly governed, particularly in this country. The kind of UHF spectrums, well, the radio spectrum's massively sort of stringently governed. Is that it? Could you apply that kind of system into these orbital highways?
Yeah, I believe that's a model that very well could work, and certainly should be of high consideration for sure.
Right, but there's one thing that I've always thought about, and I'm not sure how true this is, but is there a point where your debris problem, say if you had a sort of low Earth orbit, Kessler syndrome, and the place was just littered with debris, is there a point where it actually starts to endanger deep space missions? Like, say if we were launching the James Webb Space Telescope, is that something that then has to worry about space debris? In fact, do we have to worry about space debris for launching anyway?
Yeah, so the answer is yes. Back when I worked at NASA's Jet Propulsion Lab, we had this thing called COLA analysis, which meant collision avoidance analysis, and it was specifically for things like launch, and even when you get to Mars or whatever, the little traffic that already exists at other planets. So the answer is yes. And I can tell you right now that whatever analysis is done currently to issue out licenses for launch in terms of collision avoidance, there's so much that we don't know about that it's pretty much guesswork, which is really frightening. And yes, absolutely. I mean, here's the thing. If astronauts, I spoke to one of a good friend of mine, Susan Helms, a retired astronaut. She told me that when she would go into certain modules up there in the space station, that you could hear noises on the outer shell. You could hear ping, 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 and all this stuff was particles that were just hitting the space station, and it was fairly frequent. That's scary, and we haven't gotten the science that really delivers this knowledge so that we can make informed decisions. Again, we're out in front of the headlights. We're guessing, we're rushing, and that to me is very scary.
Yeah, this is a really, really fascinating subject. I mean, and I could keep you. I've already kept you for a long time. I could keep you on for absolutely hours and hours and hours. We've obviously got a pretty clued up listenership for the podcast. Is there anything that the listeners can go and do and help or find out more?
Yeah, so I would say this, right? One, really, try to engage with the people in, whether it's government or the scientists involved in space, and just kind of get coached up on what are the activities, what are they trying to do, and just get informed, get as much information as possible. Two, seriously consider my plea to look at models like this traditional ecological knowledge and use that as a lens to say, okay, you want to launch this thing, you want to do this, that, or the other. How does that show me how you're applying, known tenets of sustainability in what it is that you're doing in your activities? If you say that you want to give me this service more cheaply, are you doing that in a way that's long-term sustainable? Will I have this service in 20 years if you do this? And just kind of try to get involved in the narratives that way. I think that's the low-hanging fruit. That's the easiest thing to do. And hopefully, again, we see activities like this Ascend event that's going to happen in November that open this up to not just being diverse but inclusive, meaning giving the diversity a voice, part and parcel in some of the decision-making processes with what we do with this, finite resource that we call near-Earth space.
Has there ever been anyone that's gone round canvassing people that don't, presumably there's, pockets of population that know nothing about any, IACs happening or any of these other meetings happening. Does anyone actually go out and sort of try and canvass opinion or try and drill down into populations of people that have a stakehold in it but don't know that they have?
I would say, sadly, Matt, I would say that I'm probably one of very few people doing that. I mean, people all the time are like, "Oh, why are you talking to software developers?" Or why are you part of this Armadillo Con thing that is basically for sci-fi writers and blah blah blah. Like, what does that have to do with orbital debris? It's like, back to what we're discussing. Everybody needs to know about this stuff and be given an opportunity to participate. And so, yeah, I actively do that. There are very few other people that do that. There's just not enough of us, actually.
Where's a really good place to start with the sort of traditional environmental solutions? Where's a good place to actually kind of get more clued up on that?
Yeah, so this is something that I've just been researching online. UT Austin has an Environmental Sciences Institute where I've started a program in space sustainability. And yeah, there's some discussions that I've already had, along with this podcast and other venues about this stuff. So I would just say, just start looking at traditional ecological knowledge online and just getting versed with what the tenets of that are, and then imagining how these things could be applied to space. And I guess the last thing for me to mention is I'm very keen on the possibilities of me getting more involved in more kind of TV, film type activities to really get the message out there. And so I've already been talking to folks in different market areas in TV and film about developing some sort of programming that can help reach out to people. So if anybody's interested in that, then I'd be very keen to hear from them.
Well, fantastic. I'll put your contact on the blog as it goes out with the podcast.
Excellent.
Thank you very much. Well, thank you very much for joining me. I'll let you get on, and I'll let you get on cracking what is one of the most difficult nuts.
Thank you so much, Matt.
The Interplanetary podcast is alive!
There you go.
That was ace, wasn't it?
Very, very cool. There's quite a few ideas that I hadn't really considered in there, and
Really is.
Yeah, I'm going to have a look at that whole idea of TEK, traditional ecological knowledge.
There we go.
Concepts. That's what I kind of really like, that whole idea. So I'm going to look into that, Jamie, as part of space environmentalism.
Well, it sounds like another podcast to me.
Definitely do a few podcasts on that.
I think we should.
Got a bit of audio that I've been keeping that I might stick on the Patreon feed soon of an interview with the European debris controller at Darmstadt.
Matt, you mentioned Patreon. How do you become, if you're new to the show for the new year, maybe someone's recommended you some new podcasts to listen to, and somehow this old nonsense came up. How do you become a patron?
You go to www.interplanetary.org.uk.
And why are the patrons important to us?
They're so important because they mean that we can actually do this. It would sound like this without the Patreons. That's it.
I apologise to everyone else who was hurt by that loud whistle. But Matt is true. It's very, very true. We rely on you guys. And also, get in touch. We love it when you get in touch. Let us know your thoughts for the year. What are you excited about in 2020? Have you got any stories you think we should cover? People you want us to interview? Let us know.
Jamie?
Yeah?
I think we should let the Spodcats enjoy the new year, 2020. So glad to have you all back again.
It's going to be an exciting year, and we're here every step of the spaceway.
Oh man, there's some exciting things. We're going to go on tour, aren't we?
We are going to go on tour, big time. BT.
We've got the 200th episode coming up this year.
Yeah.
And we've got definitely we're going to be appearing live at the Science Museum at some point.
That's well exciting, isn't it? Imagine us there.
Yes, it's going to be brilliant. So everyone, time to do something else.
Bye-bye, everyone.
Bye-bye.
Have a good weekend.
See you soon. Bye-bye.
Bye.